Alright, so my topic is infrared spectroscopy. So it was first introduced in 1903 at Cornell by William Coblenz, and it uses the electromagnetic spectrum, the infrared section. By the 1950s, it was made kind of a standardized procedure. It's used to determine like chemical applications of polymers and like just kind of what they're best going to be used for. The electromagnetic spectrum has three different regions. The near region, which is, they're all measured in centimeters to the -1. So the near region is from 14,000 to 4,000 centimeters to the -1. The mid-range, which is 4,000 to 400 centimeters to the -1. And the far range, which is from 400 to 10 centimeters to the -1. So during the test, infrared light is shot at your test specimen, and during the test, your specimen will do usually one of 6 different vibrational acts. They can be symmetric or asymmetric stretching, rocking, scissoring, bending, twisting, or wagging. So when infrared light is when the test specimen is exposed to infrared light, that's kind of determines what kind of vibration it'll do, and like what kind of polymer you're testing. The most common two are stretching and bending. So like I said, as it is exposed to the light, it does one of the 6 different vibrational actions. From the test, you get a wavelength, and you can determine the wave number and the functional group that it's a part of. The functional group helps you determine like the molecular makeup of your polymer, and then that can also help you determine the different kinds of applications that your polymer can be used for. So for example, some polymers don't have a high melting point or something, or things like just basic characteristics. So some polymers are better in certain applications. So if something's going to be high heat, you're not going to want to use just like regular polypropylene or polyethylene. You're going to want to use a polymer that has higher heat capabilities, so you're not too worried about the polymer melting when it's at the highest region that it's going to be at. So the two most common, or there's I guess 2 different ways that you can use your infrared spectroscopy test. The main one that's used is single beam, and that's just exactly as it sounds. Single beam is going to use one beam that's shot at your test specimen, and then from there you're going to get your graph. You can also use double beam, which with double beam you have your source light that is shot at a beam splitter, and one of those beams is going to go up towards a fixed mirror and then reflect, while another one is going to be shot through at an oscillating mirror, and then those will then go down to your sample, which has the detector behind it, and then you'll get your graph that you need. So you can use these in organic or inorganic compounds. It's really used to determine the functional groups of the molecules and compounds, and then it really the main use for it is to determine the applications that your comp that is best suitable for your polymer, and if you might need to change your polymer due to the application that it's going to be in, or if it's going to be if that polymer is going to be suitable for your application that you have to use it in. And that is it.